On the client side, you can switch the parent POM by doing the same boot cloud replacement as we did in the server. But this might not be desirable in every conceivable situation. It is likely that you may already be using the parent POM for a different purpose. So, if you would rather not change the parent, just add a dependency management section with the Spring Cloud Starter parent. The end result is exactly the same in terms of the Spring Cloud behavior. I would expect that most real-world applications would employ the technique that you see at the bottom of the screen here. Spring Cloud Starter brings in the basic Spring Cloud dependencies. For our purposes, that means the config client. This is the only dependency we need on the client side, and you'll see this dependency is used in the remainder of the projects in this course for the most part. Next, there are two properties which we need to configure as soon as the server starts up: the name of our application and a location of the config server. Because these need to be loaded early, we will put these in the bootstrap properties, or YAML file if you prefer to use YAML. Now in Spring Cloud, what actually happens is that the application context is initially loaded by using the bootstrap properties, or YAML file, and it connects to the configuration server to obtain additional properties, and then these values are used to control a separate application context that is loaded using the application properties, or YAML file. So there's actually two application contexts loaded. One is really bootstrapping the application, and then the other is the main startup file that happens afterwards. Otherwise, there's no code at all. The client will connect at startup time, then contribute the discovered properties to the main application context when it starts.
So the pieces are very easy here. Let's take a look at some of the details here. First of all, let's talk about something called an environment repository. The Spring Cloud Config Server uses an abstraction, an interface actually, called an environment repository. Now at the time of this writing, there are two implementations that are available to you in Spring Cloud Config. There is a Git-based implementation and a native implementation. Native basically means local files, flat files. Now, if you have a different source control system that you want to use, or some other source of configuration information that you want to use, all you would need to do is provide your own implementation for environment repository. So if today you had to use Subversion or another source control system, you would just implement that interface. In fact, before you do, you might want to check to see if such an implementation has been added to Spring Cloud or has been contributed by someone in the community. It's very possible that someone would. Now, regardless of where the repository is, we need to talk about what you actually put in the repository, how it's organized. What you do is you put flat files in the repository. Now, the configuration files that you put in there are expected to abide by a naming convention. It's a very easy naming convention. The basic part of the naming convention is that a file should be named after the Spring application name that it corresponds to, and then a dash, and then the profile that it should be activated with. And you can use either YAML or properties. The YAML happens to take precedence. I'll discuss YAML and properties in just a second. Now, the Spring application name is the very property that was set by the client application's bootstrap YAML or properties. Let me go back a file or two. Do you remember this slide that we just left? Look at the bootstrap properties. See the Spring application name? I call this lucky word. That's the application name. So the Spring application name is the thing that is set by the bootstrap YAML or the properties. Now the profile is the client application's active profile. Spring.profiles active, you've probably heard it as. Now the profile is set various ways. If you're unfamiliar with Spring profiles, it would be good to go back and make sure that you are familiar with this concept. In a nutshell, it basically means that I can activate an application to work in different modes. So I could run an application in test mode versus production mode, or I could run something in North American mode versus European mode for changing the behavior of the application. And I can command the application at runtime to honor one profile over another. Now, when it's time to actually obtain the settings from the server, what your client application is actually going to do is it's going to make an HTTP call, and it's going to call the server import the URL that you specified, and it will actually specify, it will use its own application name as a key, and then it will assemble the URL with a slash, and then it will add the active profile. If there is no active profile, it will use the default profile. If no, the way Spring applications work is if you do not specify a profile, that's perfectly fine. One will be specified for you called the default profile. So basically the Spring application name and then the profile, if any, or the word default. The Spring clients do this automatically on startup. If you're using some other language or technology, then this is all you would have to do is make that call and interpret the results. The results come back in a JSON format. You'll see this in the upcoming exercise. Now, the best way to understand the environment repository and its organization is by example. Again, you can take a look at the Spring Cloud reference documentation on the web to see this, but let's just go through a quick example here. Let's assume that I have a client application, and I have named it Lucky-Word, Lucky-Word, and I have activated a profile of North America. So when the application starts up, the Spring Boot client will make a request automatically, and it will actually ask for /Lucky-Word /North America. And you can try something similar to this in the upcoming exercise. Now, when the Spring Cloud Config server consults the files in the repository, it will look for files that match the application name and the profile specified. So let's take a look at these files. Let's imagine that we're looking at some flat files someplace, or we're looking at some files out on a GitHub location. The first file is called Lucky-Word default YAML. This file would happen to be ignored, and the reason it would be ignored is because it contains the word default. Well, in my example, I'm specifying that I want the North America profile, not the default, so that would ignore that. If I had a file that just contained the application name, that would be included, and all of the properties that were expressed in that file would be included. Now, it says included as a second precedent. That's because, look at the next file. It's called Lucky-Word North America. This is specifying specific properties that match my indicated profile. So Spring Cloud Config Server will take the properties that are specified in here, and they will trump, they will supersede anything that happens to be set with the same name in the Lucky-Word file. The next file is Lucky-Word Europe. Well, Europe is another profile, so that would be ignored. Lucky-Word Properties. This would be included because, just as Lucky-Word YAML is, it does not contain the name of a profile at all. It happens to be as the third place winner here simply because Spring Cloud Config Server happens to look at YAML files over property files. One has to come first, right? And then this other file here, another app YAML, that's completely ignored because it doesn't even match the application name. Now there's more to it than I've described here, but this is just the basic idea. You put files in there, regular YAML or property files, name them after your applications and profiles, and there is a very deterministic way in which the properties will be interpreted. Now, YAML and properties files. If you already are very familiar with YAML and properties file, you can skip over this section, but I wanted to include this because in the upcoming exercise, you're going to deal with both of these. Spring Cloud Config Server can serve up settings stored in either YAML format or standard Java property files. YAML happens to stand for yet another markup language. Both of these have advantages. If you are an experienced Java programmer, I'm sure you've seen property files, like you see here on the left. YAML files are popular with folks, say, from Ruby on Rails background or some other technologies. It's a nice little compact format. A YAML file starts with 3 dashed lines, like you see here, and it is a hierarchical file based on spaces. The indenting must be done with spaces. 2 spaces equals 1 indenting level. And you can see here that there's less typing because the name and locations don't have to have spring.config in front of them like they do in the properties file. Same thing with the profiles. You can see that by the indenting, it belongs to the Spring group. So it's a nice way to organize things. Both formats use the pound sign as a comment. Uh, Both have advantages and disadvantages, and the idea is that Spring Cloud Config server will employ both of these. And the client, by the way, doesn't really care how the server is obtaining these configuration values. Now, the one advantage amongst many that a YAML has over regular properties, just so you know, is a YAML format can hold multiple properties within a single file. A moment ago, I said that a YAML file starts with three dashes. Technically, that's technically true. Spring and a lot of other technologies will silently accept you if you happen to leave that out. But when you embrace that, it actually allows you to put multiple files, so to speak, inside one file. So you can see here, if I wanted to have a lucky word east and a lucky word west, two different profiles, if I used properties, I'd have to have two different physical files. If I used YAML, then I could put these into one file. With inside the top of the YAML, I just say the Spring profile that it applies to. Okay, now let's talk about the client side a little bit more because you might have some questions that I can answer by this. It's important to understand how properties work within Spring applications. A lot of times I find that people have used Spring for years and aren't really 100% sure how they work. Spring applications, at least for the last few versions, have an abstraction called an environment abstraction. There's an interface called environment. Okay? And every Spring application context has an environment object in it that is populated by the container. One of the things that the environment object has in it is multiple property sources. Now, a property source is just what it sounds like. It is a source of properties that came from somewhere. Now, Spring application contexts will automatically populate property sources from the environment variables where your application is running, and the system properties that you specified when you launched the application. And if you're running in a Java EE application server, any JNDI things that you have specified. What most developers are familiar with when working with Spring is specifying their own property sources to pick up their own external property files. But it's important to know that Spring also has property sources from these other places as well. Now, when a Spring application starts up and it uses Spring Cloud Config on the client side, the library simply alters the setup behavior just slightly to add another property source. That's really all it's doing. And it populates that property source by connecting to the server over HTTP using the URL that you've seen here, making the call, getting the response back, and populating a property source. Now that property source, depending on your preferences, will supersede the other property sources. That's kind of the magic of all of this. So you can specify things locally and then have your Spring Cloud Config overlay or override those values. So the end result is the properties that are described by the server become part of the client application's environment. This is actually quite simple if you think about it. I've wondered why I haven't written something like this. But if you think about it, it's a little bit complicated to do this with a Spring application because you have to understand the details of the application container when it starts up. So you say, what about non-Java? What if I'm not using Spring? What if I'm not using Spring Boot? Well, the Spring Cloud server is actually exposing its properties over a RESTful interface using HTTP. Most languages that you and I know of can make an HTTP call. Most languages nowadays can do a RESTful call and interpret a JSON response. So it is reasonably easy, or absolutely possible, let's put it this way, absolutely possible to make the call from the server from any application. So if you're in an environment that uses half Java and half .NET, you'll probably have a little project to set down and code a little bit of .NET code to make that call and alter the way your .NET applications digest it. But it's pretty straightforward to do. It's just not as automated as using something like Spring. Now think about this. What if the configuration server is down? This is something that we have to think about very carefully in cloud applications because we have to think about in microservices, excuse me, when we have different microservices talking to each other? What if something's down? Have to think about that. Well, first of all, the Spring Cloud Config server is recommended to be run in a multiple instance setting. So if I were running on a Cloud Foundry or a Heroku or an Amazon or something, I would have several instances running behind a load balancer. Now, as long as I have some type of elastic runtime that keeps those instances up, the downtime really should be a non-issue. So that's number one. But aside from that, the client application can specify the ultimate policy of how to handle the missing configuration server. This is really a matter of application code when it comes down to it. There is a setting called Spring Cloud Config Fail Fast. You can set this to true. The default is false. So by default, and you can see this in the upcoming exercise, in the upcoming exercise, we'll have a client and a server. You can try it, shut down the server and start the client and see how it behaves. The default is that we don't want to fail. The client doesn't want to fail. We want it to start up and see what it can do. If you don't want that behavior, then you would set it to fail fast. And that will make the client very finicky. It will say, I'm not going to run without my configuration server being provided, configuration information being provided to me. Now, the configuration server settings, I mentioned this briefly, any settings that we get from the configuration server are going to override any local settings that you may have. So one possible strategy is you can provide a local fallbacks for your settings, and then you can have the configuration server override that. So that's all we need to talk about the configuration Spring Cloud config. So there's a really great exercise that is going to enforce these principles. What you're going to do in this exercise is set up your own Spring Cloud config server, set up your own client that uses the server, and then you'll also set up your own repository in GitHub or another Git repository that serves up the configuration information. The instructions for this are on the URL that you see here. It happens to be in the same location where the student files were downloaded from, so just go to the lab instructions folder and you can see the lab instructions there. This would be lab 3.